You know, for the first time in over half a century, we are actually going back to the moon. But you can just forget those grainy, black and white images from the past. This time, it's not about planting a flag and heading home. Oh no, it's about building a launch pad to Mars. And the biggest difference? This time, it's not just one country's mission. It's a massive, global push out into the cosmos.
So, to really get our heads around this incredible new chapter, we need to answer 5 key questions. First, why are we going back now? What's the point? Who else is in this new space race? What's the one thing that could literally stop us in our tracks? How do you keep astronauts sane when they're millions of miles from home? And maybe most important of all, what's the invisible lifeline that connects us to all of it?
All right, first up, why even bother going back? We've been there, we've done that, right? Well, it turns out the goals this time are worlds away from just leaving a few footprints like we did back in the Apollo days. This is a whole new ballgame. And this is what's so fascinating to scientists now. See, the moon has no real atmosphere, no geological activity to speak of. That means its surface is a frozen, pristine record of our solar system's entire history. It's a 4.5 billion-year-old time capsule, holding clues about how the Earth, the planets, and even the sun were born. So NASA's Artemis program, it's not just a mission. It's like an archaeological dig on a planetary scale. And this slide, well, it lays out the strategy perfectly. It's a really clear 3-step Moon to Mars plan. Step 1, test everything on the moon first. It's our cosmic backyard, the perfect place to figure out the hardware, the habitats, and all the skills you need to survive on another world. Step 2, build the gateway. Think of it as a small space station orbiting the moon, a waypoint for deep space travel. And then finally, step 3, you use that whole setup, the moon base, the gateway, to launch the first human missions to Mars. This isn't a short-term thing. It's a real long-term vision.
Okay, so that brings us to our second big question. Because while NASA's Artemis program gets a lot of the headlines, it is far from the only game in town. What we're witnessing right now is a new, truly global race into deep space. And this chart, wow, it really shows you the key players. Of course, you've got the US with Artemis, aiming for those crewed landings and then onto Mars. But then you have China's incredibly ambitious Chang'e program. They're planning a joint lunar base with Russia and are already sending missions to Mars and even Jupiter. And don't forget India. ISRO has its own crewed missions on the horizon and probes heading for both Mars and Venus. It's official. This is a truly multipolar space age. But you know, getting there is one thing. Surviving the trip is a whole other story. And that brings us to the single greatest physical threat to any astronaut who leaves Earth's protective bubble, cosmic radiation. This invisible storm of particles could be the showstopper for all of our deep space ambitions. So what is this threat exactly? Because it's probably not what you're thinking. It's not equipment failure. It's not tiny meteoroids, though those are definitely risks. No, the biggest threat is the constant, unavoidable storm of high-energy particles that fills our entire solar system. Now just look at this comparison. It's night and day. Here on Earth, we basically live under a double shield. We've got a powerful magnetic field that acts like a force field, deflecting particles, and a nice, thick atmosphere that soaks up whatever gets through. But Mars, it has neither of those. No global magnetic field and an atmosphere that's razor thin. So once you leave Earth's protection, you are completely exposed to this radiation, which can shred DNA and massively increase the risk of cancer. So how in the world do we protect them? Well, there's no silver bullet. It's a multi-layered strategy. First, you've got passive shielding, basically lining the spacecraft with hydrogen-rich materials, like water or even certain plastics. Then there's the more brute force method. Just bury the habitats under a few meters of Martian soil, or regolith. The real sci-fi dream is active shielding, creating a mini magnetic field around the ship, but that takes way too much power right now. Which leads to probably the most practical solution of all: just get there faster. The less time you spend in transit, the lower your total exposure. Simple as that. And this number right here, this is why it's so terrifying. 1.01 sieverts. That's the estimated radiation dose for just one round trip to Mars. To put that into perspective, that's like getting thousands of chest x-rays. That one single trip could max out an astronaut's entire career limit for radiation exposure. This isn't just a risk to be managed. It's the fundamental barrier to survival that we absolutely have to solve.
Okay, so we've covered the physical danger, which is A lot. But what about what's going on inside the helmet? The psychological toll of being isolated millions upon millions of miles from home, maybe for years at a time. That's just as big a challenge, if not bigger.
This quote from a recent research paper puts it pretty bluntly. Being cooped up in a tiny space with the same few people, seeing Earth as nothing more than a pale blue dot in the sky, well, it can seriously mess with your mental health, team dynamics, and even your basic ability to think clearly and do your job. These are what NASA calls the 5 great hazards of spaceflight, and just look how many are psychological. You're in a hostile, closed environment. You're completely isolated and confined, and you're unimaginably far from home. That distance creates a communication delay, up to 40 minutes for a round-trip message to or from Mars. Think about that. You can't just call Mission Control for help. You are utterly, completely on your own. So how do you fight something like that? Well, technology is offering some pretty amazing solutions. They're developing dynamic lighting that perfectly mimics an Earth day to keep sleep cycles and mood stable. They're going to use virtual reality to give astronauts a much-needed psychological escape. You know, a walk on a virtual beach or through a forest. And maybe most critically, they're developing AI-powered therapy. Since you can't have a live chat with a therapist because of the time delay, an AI can provide confidential, on-demand support 24/7 right when an astronaut needs it most. All right, this brings us to our final big question. With all these spacecraft, all these future astronauts venturing so far out into the solar system, how do we talk to them? How do we get all that incredible data, the images, the health monitoring, back to Earth? It all depends on one incredible piece of global infrastructure. It's called the Deep Space Network, or DSN. You can think of it as the nervous system of space exploration. It's not just one antenna, it's a worldwide network of absolutely massive radio dishes that act as our eyes and ears across the entire solar system, talking to dozens and dozens of missions all at the same time. And the genius of it is really in the design. The DSN has 3 main facilities, one in California, one in Spain, and one in Australia. They're each placed about 120 degrees apart on the globe. And what this does is ensure that as the Earth rotates, no spacecraft is ever out of sight. Before one station dips below the horizon and loses the signal, the next one is already rising, ready to take over. It creates a perfect, unbroken, 24/7 lifeline to all of our explorers. And what's really amazing is that this isn't some top-secret classified system. You can go online right now to NASA's DSN Now tool, and you can see exactly which antenna is talking to which spacecraft in real time. Whether it's a Mars rover, the Voyager probes, or the James Webb Space Telescope, you can literally watch humanity's conversation with the cosmos happen live. So here we are. We're heading back out into deep space with new goals, incredible new technologies, and new global players all over the world. But as this amazing new era unfolds, it all leads to one final massive question. As space gets more and more crowded with companies and countries, who writes the rules of the road? Who manages all that traffic? Because figuring that out might just be the most important exploration we have left